Now today I have discussed symmetrical component based on problem. So first of all, see on the screen. Question number 1. A three-phase transmission line supply a delta connected load Z. The conductor C of the line develop on open circuit fault as shown in figure. The current in the lines are as shown on the diagram. The positive sequence current component in line A will be. Our motto determine current in line A. Positive sequence current component in line A. Okay. Basically our motto determine IA1. Okay. IA1. So how can we determine? First of all, this is the delta connected load. Make like this one. Okay. IB you can also written as that is 10 and this one is also written as minus 10. Okay. Now open, this one is open, it means IC is equal to 0. That's why I represent here. Now I know that what about IA1 in the terms of IA, IB, IC. IA plus alpha IB plus alpha square IC is the relation between phase current and positive sequence current component. Okay, that is phase current IA, IB, IC. I have already discussed how can got it. So 1 by 3. And what about alpha? Alpha is the 1 plus 120 plus 120. Alpha square is minus. Okay, so 1 by 1 that is 10. Alpha that is 1 at the angle 120 and this is 1 is minus 10, so it is written as 120. After that 10 by root 3, sorry 10 by 3, 1 minus 1 at the angle 120. So if you can solve with the help of calci. 1 minus 1 at the angle 120, we got 7.732 at the angle minus 30 degree. Okay, so 73.32 divided by 3, we got 5.7733 at the angle minus ampere. This is the final answer. Which one is closer? Option A is closer to your result, so option A is correct. Okay, first of all make it. Now another way, if question asking determine positive sequence current in B, in phase B, it means IB1. Clear? So how can we determine IB1? IA1 like this one. I know that if there is IA1, IB1 like this one and IC1, that is minus 120 and here that is 240 and here that is 120. Our motto determine IB1. So how can we determine IB1? The relation between IB1 and IA1 is minus 120. Clear? So what about IA1? IA1 is 5.777 something and this is 5.77 at the angle minus 150. Okay, similarly if question asking determine positive sequence in C component, okay, positive current in C, determine positive positive sequence current in C component. So how can we determine? That is IC1. IC1 is that is 5.77. Sorry, first of all, according to this concept IA1 at the angle minus or you can say this 120 plus 120. So IA1 is 5.77 at the angle 90 degree plus 90. Okay, minus 30 plus 180 120, we got plus 90 degree. Okay, make it. Is on. Now second question, read on the screen. A three-phase A balanced delta connected load is connected to an unbalanced three-phase supply. The symmetrical component of the line current are like this one and like this one. The symmetrical component of phase current are. Our motto: determine IA1 and IA2. This value and this value are given. Okay, so it means IB this is equal to IA1, I of A, IB1, IB2 and IB0, that is line current. Okay, so what about IA? I know that is IA1, IA2 and IA0. And what about phase current IB? That is alpha square IA1, alpha IA2 and that is IA0. So what about IAB? That is IA minus IB. Clear? So 1 minus alpha square, that is IA1, 1 minus alpha, that is IA2 and this value is 0. Okay, this one and this one are same, so compare this one and this one and that is 0. So IB1 is 1 minus alpha square into IA1. This value is given I1 at the angle theta 1 and this value is root 3 at the angle plus 30 degree. So if you solve it, 1.7322, okay, 1 minus 1 at the angle minus 120 okay, so clear. So IA1 is I1 at the divided by root 3 and this angle theta 1 minus 30 degree, that is IA1. Similarly, what about IA2? This one compare to this one. Okay, so IA2 is written as I of AB2 divided by 1 minus alpha and IA2 is I2 at the angle theta 2 and this value is root 3 at the angle minus 30 degree. Okay, so and this value we got I2 at the angle root 3 at the angle theta plus 30 degree. This is the final answer, make it. Okay, so finally which option is correct? D is the correct option. Now next question, read first one. The three-phase star connected resistor of 1 pu are connected to unbalanced three-phase supply. The load neutral is isolated. The symmetrical component of the line voltage in pu are given like this one. If all in pu, calculate the respective base value. The phase to neutral sequence voltages are. Our motto: determine sequence voltages corresponding to given. Our motto: determine this one and this one. Okay, and V of AB1, V of AB2. So basic requirement corresponding to this solved question: V of AB. I know that V of AB is written as like this one and V of AB 0. Okay, line that is phase A, phase B, phase C, that is VA voltage, VB voltage and VC voltage, V of AB, V of VC and V of CA. Clear? So what about VA? VA is VA1, VA2 and VA0, and VB, that is alpha square VA1, alpha VA2 and VA0. Clear? Now V of AB, V of AB means VA minus VB, that is 1 minus alpha square, that is VA1, and 1 minus alpha, that is VA2, and this one is 0. Okay, VA minus. So if you compare V of B1, that is 1 minus alpha square, that is V of A1. Okay, this value is given x at the angle theta 1, and this value is root 3 at the angle plus 30. So V of A1, that is x by root 3 at the angle theta 1 minus 30 degree. Clear? Similarly, this one is compared to this one. So V of AB2, this is equal to 1 minus alpha into V of A2, and V of A2 this is equal to, that is, this value is y at the angle theta 2 divided by 1 minus alpha. 1 minus alpha is root 3 at the angle plus theta, sorry, minus theta. Okay, so V of A2, we got y by root 3 at the angle theta 2 plus 30 degree. Clear or not? So first of all, what about given line voltage of phase, line voltage of positive sequence and negative sequence are given like this one. So we are focused on VA and VB. VA and VB are given. So V of AB is equal to VA minus VB, and this one compared to this one, and this one compared to this one. So VB1 is given x at the angle theta 1. So with the help of this one, we got like this, and this value are given. V of AB2 is y at the angle theta 2. So y at the angle theta 2 divided by root 3 at the angle minus theta minus 30 degree, and solving, find the answer. So what about V of A1? We got x at the angle root 3 theta 1 minus 30 degree, and this one is y divided by root 3 at the angle theta 2 plus 30 degree. So which option is correct option? That is C. C is the correct option. Okay, make it. Already the question. A unbalanced three-phase system, phase current IA like this one at the angle minus 90 degree pu, negative sequence IB2 is given 4 at the angle minus 150 degree, zero sequence current IC03 at the angle 90 degree pu, the magnitude of phase current IB in pu. Okay, our motto determined IB current. IB current means, that is, first of all determine IB1, IB2 and IB0. Clear or not? What is the meaning of this one? And after that we got our motto, because focus on this one. So first of all determine this current, phasor sum of IB1, IB2 and IB0. Okay, so how can we determine? Look at the question. IB2 is given, IA is given, IC0 is given. This is also written as root 3j, and this one is also written as minus j. Clear? 3 at the angle 90 degree, it is written like this one, and this one written like this one. Okay. Now IB2 is given, but our motto determined IB2 is given, IB0, IC0, IA0, IB0, IC0 are same, zero sequence current are same. That's why written here. Okay. Next one, IB2 is also given, that's why. But what about IB1? We are focused on IB1. So how can we determine IB1? Okay. I know that if you draw the positive sequence component, that is IA1, IB1 and IC1. Here IA2, IB2 and IC2. Clear or not? Sorry, that is B2 and that is C2. Okay. In case of positive sequence, in case of negative sequence. Okay. Now this one is -120. So IB1 is written as IA1 at the angle -120, and here that is 120. So IB2 is written as IA2 at the angle plus 120 degree. Clear or not? Clear? Now according to question, IA means IA1, IA2 and IA0. Okay, IA is given 1 at the angle -90 means -j. What about IA1? No idea. What about IA2? IA2 determined with the help of this. Okay, this value is 4 at the angle -150, and that is IA2 at the angle plus 120. So what about IA2 is 4 at the angle -270. It means that is -4j. So put here plus 4j. So plus 4j, and this one IA0 is given, that is 3j. So finally, what about IA1? IA1 we got -8j pu. Okay, -8 pu. Clear? -8j pu. Now, or you can say that it is written as -90 degree pu. Clear or not? That is IA1. Okay, so what about IB1? If this value put here, then we got IB1 is 8 at the angle -90 and -120, that is -210 degree. Okay, now all value put here. IB1 is 8 at the angle -210 degree, and IB2 that is 4 at the angle -150 degree, and this one is 3 at the angle 90 degree. Okay, after solving this value, what about magnitude of, that is 8 at the angle -210 plus 4 at the angle -150 plus 3 at the angle 90. So finally we got, that is 11.5553 at the angle 154.30. Clear or not? So what about magnitude of IB? That is 11.53 pu. Okay, and which one is correct? C is the correct option. So very clear. How can got IB? I know that IB is equal to IB1, IB2, IB0. B2 and B0 are given, but our motto, we are focused on IB1. So how can we determine IB1? I know that positive sequence and negative sequence, relation between IB1 and IA1. If you determine IA1, then we got IB1. How can we determine IA1? I know that IA is given like this one. So if you determine IA2, so how can be IA2? If you relation between IA2 and IB2 like this one, putting this value, and we got IA2. IA2 put here, IA1, IA0 put here, and IA put here. then we got IA1. IA1, with the help of this formula we got IB1. Okay, put this value IA1 in this equation, we got IB1, and IB1 put here, and IB2 already given, IB0 already given. This value solving with the help of calci we got 11.53 PU is the magnitude of IB. Okay, make it.